answer to market needs. And we actually accompany projects since the inception with our customers, with prospects. We go from the design phase all the way to putting the tickets or the price stickers for the big box stores, or for, we just added the e-commerce section that's going to help us, even further service our customers. Just wanted to, this is going to be a short period of time to talk about all this stuff. So I do apologize if some of this stuff seems to be, I'm going through it too fast. I also apologize if it's something that's maybe trivial for some of you, and that, we probably should not spend, if you might think that we shouldn't spend so much time on it. But given the nature of our audience, we have, from all levels of filtration and paint overspray collections. So we try to make it kind of a mix that, helps everybody, basically. So we're going to be talking about paint overspray filtration essentials. What is needed to know? What are people talking about when they talk about overspray filtration? The types of filtration systems, we'll try and go through that as fast as possible. I know a lot of you know this stuff already. The PC pleat solution, and we'll give you some concrete examples of success stories, and they're becoming more and more as we go. It is really a solution that is proven to be the in sync with what the market is going, moving from one type of filtration system, which was the water scrub, to the dry filtration. And this product just answers that. And then at the end, we're going to introduce a new product that we just launched. So the essentials that we're talking about. There are key terms, and I tried and simplified them, and not too many of them. The airflow volume, or the airflow velocity. Volume determines the amount of air going through a surface area, specific surface area, or an opening or a duct. And it's measured usually in cubic feet per minute or in cubic meter per hour in the SI units. The velocity is the speed at which, at any given point in a surface or a plane that represents the area where the filter is, or any point really in the airflow duct, that tells us at what speed that movement of the air is going through that area. Airflow resistance, pressure drop. Anytime we have airflow, if we put an obstacle, and a filter is somewhat an obstacle to that free airflow before having a filter in there, it does create pressure. It does create a differential pressure between what's before the filter and what's after the filter. The holding capacity, or the capacity is the loading of the filter. The filter, if it's completely not closed or not efficient at all, it will not hold any particles. So sometimes you'd hear a filter lasted forever, but it didn't stop anything. But for a filter that has efficiency or arrestance, as we mentioned here, it's going to have some holding capacity. And that capacity, we use the word capacity because at one time, it's going to stop taking those particles. It's going to stop receiving. And that will determine the service life of the filter or the filter system, because it can be a filter that's just one or a two-stage filter. The airflow, basically, it's the velocity times the surface area. So the velocity of the air and times the surface area of whatever the area of the filter that's available for filtration. Q is the airflow. V is the velocity, and the area of the filter is A. Your air volume is gonna, the units do tell you that it's cubic feet per minute. So that's the, if you want to measure that Q. The pressure drop, again, you have before the filter and after the filter, two different pressure levels or two different pressure readings. The old way of reading this was the manometers that uses mercury or some kind of different liquids as well to measure the difference between the pressure between the two sides. The one instrument that's most used today is the magnehelic gauge. That's what you have in a lot of the spray booths. I'm sure that when you look at a spray booth or a spray plant line, you're going to see a lot of these on that. And we're going also a lot of different new manufacturers, or they're going into more digital indicators of pressure drop or pressure differential. It is measured in water column or water gauge, inches of water, or in Pascal. And as you can see, as for a clean filter, well, if you increase velocity, the pressure drop will increase as well. So another term is filter efficiency. When we talk about efficiency, sometimes you wonder why you hear efficiency and sometimes you hear arrestance. The difference between the two is in the industry of filtration, efficiency is used for the micro type filtration, for the smaller particles, for the, say for HVAC, for the high efficiency levels. But when you're talking about arrestance, you're talking about a measurement of how much a filter does stop by weight. It's not measured by particle sizes or particle distribution or efficiency level at the micro level. So whenever you're talking about coarse filtration, you're talking about more about by weight arrestance. It's a modified ASHRAE norm that is used for paint, for example, that does apply in this case. And the unit for that is percentage. Efficiency or arrestance, we should talk about it. So again, it's really interchanged. It's used a lot, one or the other. Depends on who you're speaking with. So let's talk about arrestance here and the importance of that percentage and so on. For any given application, let's assume we have an application that's spraying 1,000 pounds of paint. One wonders, how much is getting out there given a certain efficiency. So if you say, for example, you have 90% efficient, that means that of the 1,000, 100 pounds of the paint is actually being exhausted. That's like an overspray is released to the environment if your filter is just 90%. Some people feel that 90% is enough, and there are industries where they do until they're caught by the EPA or by actually caught by mistakes that they have to correct in equipment, in the fan, paint, getting on the stacks, painting the neighbors' cars, and so on. That's very clear. I mean, 90% is not enough. There's a lot of paint given this here. Now, the other question is, what is the difference between 98 and 99.8 or a 95 and 98? One would say 95 is great or 98 is fantastic, but that small change in efficiency between 98 to 99, it's 1.8% in the system, is a big difference in terms of how much more, the multiple of particles that are letting out into the environment. So this is why we do care a lot. I mean, we mentioned efficiency because we've seen things that happen. From serious to more than serious issues because paint is caught in the stacks and in the framework or on the fans or basically in the neighborhood, basically. So the one thing about efficiency, when we talk about efficiency, we're talking about an efficiency of a particle that's slightly different from the dust particle. In the dust particle, you have a gas phase, you have a gas, you kind of like know what particles are coming out.
Tienen que identificar qué partículas.
You know pretty much what to expect, you know exactly what
Sabemos que se tiene que esperar de ello.
different because the particles are different sizes. The distribution is not very regular.
Manuel,
Yes. Yeah.
we expecting a lot of noise. I don't know if it's your microphone, my computer. Can you hear me? Bueno, los demás gente me escucha bien a mí o es la señal completa.
I hear you very clearly.
Okay. So yeah, maybe it's your microphone, but it's your connection that is making that that you are cutting during.
So it is cutting a little bit?
Yes.
Okay. Is it cutting now?
No. Now you can.
Okay.
It's okay.
So I'll stop moving back and forth. Sorry about that. Okay. Can you hear me now?
Yes.
Yes. Okay. Very good. So the particle for
Entonces, las partículas para pintura son totalmente diferentes a las partículas de polvo, como saben, en farmacéuticos, en limpieza, en computación. Tiene ese, lo húmedo, el factor.
Quick dryness. So it could wet 1 second, 5 seconds later, it's
5 o
dry.
10 segundos.
There's a lot of static coming across. I don't know if you may want to try maybe dialing in on your phone, may come across better.
I don't, you still hearing a lot of static from my side?
No, not right now. It was better.
Okay. So I will not move anymore. Moving on from efficiency, we talk about holding capacity. And in particular, in paint application, the surface area.
En la aplicación de la superficie que se va a ver primero en la pintura es el frente del filtro. Si comparamos un filtro tradicional de fibra de vidrio con la pintura, esto es por la naturaleza del filtro. Y aquí tenemos fibra de vidrio.
Of paint collectors, we have ample surface area that is open, and as you can see from this side view, it is loading the paint not just on the surface, not only on the front mesh, but it's also loading throughout the whole, matrix, all the way down to the synthetic that's there. The specific filter it does require the synthetic because of the nature of the particle, the size of the particle. And that's why we have what we call depth loading versus face loading. The surface life, it could be the capacity of the filter, but also there are other factors that could contribute to deciding to do the change of the filters. So first, when you reach a point where operating the spray booths becomes prohibitive, in other words, where the regulatory levels of airflow go below the floor, below the minimum level of airflow, it becomes prohibitive and you cannot operate anymore, and you need to change your filters to get your airflow to move and to get your to where you have safety, parameters that are, especially if you have operators in there. There's a minimum airflow that you need to have in there. So once you reach that area, and a lot of people would put a mark, a lot of companies would put a mark on their Magnahelic gauge, and once the gauge reaches that mark, they automatically go and change the filter. However, there are other factors. If you have maintenance schedules, You have customer preferences. For example, if the filter gets to be too heavy, they don't want their operators to lift too much. The handling issues, the safety reasons, shift changes. They don't want to, wait until the next shift because they know in the middle of the shift the filter is going to die. So they change it systematically and they have their schedule. And anytime you have a booth that is not balanced, anytime you have a booth that has too much resistance, it does immediately affect your quality because the air will create some turbulence within the booth. And then your overspray is not just hitting the filters, it could be going around and hitting the parts that you just painted. So these key terms, we summarize them. I mean, to us as filter specialists, as maintenance people, as people that care about or that are providing services to the industry, we understand these parameters. We have laws about the static pressure, we have efficiency emission maximums and so on. But also what we need to be careful about is also to explain and make sure that our end user understands the implication of each of these factors. For example, if we take all of these things that we talked about, and the question is how much? What I mean by how much is, what is it costing if one of these parameters is not where it's supposed to be? And how is it affecting cost? You take, when you have your airflow, if it's too high in one area, because the other areas are plugged and you don't have balance in your booth, sometimes it does affect your transfer efficiency. In other words, you're going to be spraying paint, and that paint is supposed to have a certain period of time to get onto the part, and then boom, goes through, and some of it is lost to the overspray when it's supposed to be at that. So the booth needs to be balanced. The transfer efficiency costs money. You need to stick to as much as possible the level that you're supposed to be at. And the first time quality does cost dollars. If your booth is unbalanced, you have particles, turbulence all over the place, you're going to have some defects. Airflow resistance and pressure drop. Again, the energy consumption, the first time quality also means dollars. To move a certain number of cubic feet per minute through a filter that's high resistance, you're going to spend a lot of energy. And in today's industry, a lot of the booths do have a drive that controls the speed of the fan to make sure the airflow is constant within the booth. So if the filter is higher resistance, it's going to work harder to pull that amount of air through. So it's going to cost money. Okay. Efficiency and arrestance. How does it affect the end user? And we need to make them aware of the situation is compliance with the environmental protection agencies in any country, really, protection of downstream hardware, and the protection of the secondary filters. Most of the time, the secondary filters or filters that are used in air makeup units are of higher cost than the pre-filters or the spray booth filters. And you would be surprised that changing your filter in the booth when you're supposed to, it's not really making you spend more money on the exhaust filter. It also is saving you a lot of money on the side of the secondary filtration, which is higher efficiency. Holding capacity, when we talked about this, what is the cost effect of holding capacity? Of course, first of all, filter cost, because you're not changing it as often, and then less downtime to change filters, lower frequency filter changes, so your labor costs will be lower, not to mention other factors like stock, like transport, and all of that stuff. So the spray booth ownership cost altogether is lower when you have higher holding capacity filtration. Now, higher holding capacity, but with efficiency, of course, because there are some filters out there that will last for months, but they're not stopping anything. They're just there, you know. Then you have other costs. The service life, if your service life is, of course, provided by that high holding capacity, is extended. That means you have process capacity, extra process capacity that you didn't have with a filter that lasted less. You have more scheduling flexibility. If at one point you're doing your schedule and you have a little bit of an increment in your production that you need, if you have a filter that can take a little bit more because of the capacity that's higher, then you're able to do that without changing, you're having to stop and change your schedules and so on. So these are the factors that these technical terms, or these terms in spray booth filtration, do affect the cost. Now we're going to talk about characteristics of the paints themselves. And when we talk about the paints, we're not going to get into heavy chemistry about the paints. We're going to talk about what paints are being used in general, where are they being applied, and how do they affect the type of paint, or the type that the paint is being used or applied. How does it affect the overspray? Because our dealing is to stop the overspray from going to the environment, or so the 3 C's of industrial paint. The first C is the coating. We have, in general, if you look at the past the surface preparation, the washing, sometimes the dipping in automotive industry, the plating with or using electricity, or to kind of prepare and clean the surface so that the paint adheres properly. The first one would be the primer, which actually is the agent that makes your paint or your color adhere to the surface adequately. The primer is also used, and it's called sealer, especially in wood industry. They do call it a sealer a lot. And it's basically to seal any porous surfaces to stop them from receiving the second coat, also to protect from corrosion and so on. The clear coat is the coating that's used to protect from the elements, heat, rain, sun, and also to give it a certain aesthetic aspect also. The cure, the second C, is the paint after it's applied. Some of it just air dried. You just leave it alone and it dries and it cures on its own. Some of it is bake dried. And a few of the paints are UV cured. So there is an action that takes place there with UV light to cure the paint. So where the pigments are, they kind of fuse together and adhere to the surface and build that film, that perfect film that you have in there. The third C is the chemistry. Some paints are one component. Some paints that are applied are two components. You'd have the paint and then a catalyst, or a paint and a hardener. It depends on the type of paint that you're using. You have also a factor a chemical factor of the paint itself is solids that are in the paint. Any paint will have some part of it that's going to evaporate and go away, and some of it that's going to dry and become particles or solids. The paints traditionally were solvent based. So there's a lot of solvents in the paints to actually make them do so that the reaction takes place for these pigments and the coloring and the protection, the petroleum and all that stuff to adhere properly. And the use of solvents, but lately with the commitment to the environment, and also because of the environmental, it's basically demanded by the environmental agencies to move towards a waterborne paint. And that's really the trend for the past, let's say, more than 10 years. And now it's becoming more and more the case. There are applications where you still use solvents. A lot of them are a lot less percentages than before. And some applications you still use them, but really predominantly it's the waterborne paints. The other element that could have an effect on the overspray structure, the overspray nature, is the application equipment. What is being used and what method is being used, and how the particles, how small or how large, or they are atomized. In other words, for them to become a fog like that, and to be sprayed into fine particles onto the surface, they are atomized. And in every atomization, there's an array of different particle sizes, particle distribution, particle size distribution, from one paint to the other, but also from one applicator to another. As you can see, these are there's manual, automatic, and then these are, I'm sure you guys know the types of different types of spray guns and bells and so on. The one thing about our product, we also manufacture the paper in that product. We slit and expand the paper. And I know there are other companies that buy the rolls and they try and make additional other products with them. We actually do that. We make it, and we build the honeycomb structures any way we want. We have an array of solutions that we can offer for specific applications. Trying to quantify now the amount. We talked about the nature of the overspray. Would like to talk about the quantity of the overspray. If I'm building a booth, for example, and I would like to know how many square feet or how many square meters of surface area that I need to have filters in, and I have a schedule, I want to plan to change my filters once a week or twice a week, or and also would like to determine the footprint of my spray booth. The first thing you need to determine is your paint, how much overspray you're going to have with the volumes that you are forecasting to apply. And that is very straightforward. The quantity sprayed in pounds, the transfer efficiency of the paint that's adhering to the part it's measured in percentage, and then the overspray, it's the excess paint that's going to be in the airflow or airstream that's not on the part, and that's what we're dealing with here. We'll take an example of, let's say, 600 pounds of spraying, whether it's a day, a week, 3 shifts, whatever. And let's take an example of 65% transfer efficiency. So every time I spray, 100 pounds, 65 pounds are going to be on the part. So that means 35 pounds are going to be in the air. So to calculate my capacity, my overspray estimate, it is going to be 210 pounds, 600 times 1 minus 65%. But the filter and the filter loading is mostly due to the dry overspray, because when you have overspray, it's a mist. So it's wet, it's got solvents in it, it's got some water in it if it's more waterborne. So with time those solvents are going to go out, going to dry, the water is going to dry. And so the most important is the dry overspray. That's what we're looking for to measure or estimate the capacity of our filter, or the need, what surface area we need for that. So to calculate the dry, you need to have the other factor in your paint, which is the solids content. It's also a percentage. Example, 40%. So I know when I'm spraying my mix of paint, whether it's 1 component, 2 component, solvent-based, waterborne, I know that the solid content when the paint dries is going to weigh 40% of the original weight of the paint. So how do I calculate my dry? I'll just take the quantity that I sprayed, and then I multiply it by the solids content, basically. So it's going to be your 210 pounds times 0.4%. And that's how you get your equation there. That's how you get your dry extract. It's also referred to it. That's going to be left on the filter. The characteristics of the overspray itself. Okay, Now we want to talk about the interaction between the mist and the filter. In other words, how does the filter, or how does the mist hit the filter? How does the filter see the mist when it arrives to the filter, to the front of it? Yeah. Does it arrive wet and, wet and very, very liquidy? Does it arrive completely dusty like powder? Or does it hit right in between? And the in between, there's three different ones there. So we use tacky, we use semi-tacky and dry, and then dust or dusty, completely dry, very fine particles on the other side. So that affects the kind of structure of the filter that you want to have in there. So we talked about the paint, we talked about the airflow, we talked about the speed, the velocity. We talked about the amount of solids. We talked about, now we're talking about the physical or the nature of the paint over spray itself. And now it could be dry, wet, whatever, but there's also a degree of aggressiveness. How aggressive does the paint or the overspray hit?
Es el exceso de rocío en el filtro. Entonces tenemos la carga agresiva. Es una carga que va a hacer ciertas grietas, ya sean pequeñas, groupies, o de manera líquida, un poco más pegajosa, pintura. Y eso va a crear ciertas ventanas como una membrana que hace estas aperturas. Entonces, cualquier vez que se tenga una ventana o apertura, hay una reducción en la superficie. Y cuando se tiene esto, hay un incremento de velocidad de aire y eso afecta el desempeño. Por cierto, en algunos ciertos tipos de pintura se hace esto a propósito, se reduce la superficie para tener más apertura en la parte de atrás, sobre todo con nuevos productos. En una carga no agresiva, esto es cómodo y deja la superficie y permite la penetración del aire y la filtración del aire. Cuando se ve de lado a lado los filtros y se fijan, va hacia abajo. Entonces se carga en la parte de atrás antes de llegar a la parte de enfrente. A diferencia de lo que
spray booth, where air is going in horizontally in the booth, where it could be.
Esta es la pared o puerta donde entraría la filtración. Hay paneles. Un panel de implantes. Y por el otro lado está el otro filtro. Aquí tenemos una cabina donde entra por una cabina de difusión hacia arriba. Y el volumen de la cabina.
Some heat areas, like if you paint here and then the part will go there to assist a little bit with the air dry, or that's, or sometimes it's in a different, kind of a chamber. It'll be a full-fledged oven. The cross-draft water wash systems, they call them cross-draft, but most of these that I've seen are what is called a hybrid cross-draft, because a cross-draft, fully cross-draft, the air would be horizontal. In a lot of these, I would see air coming in the back of the booth and then going 90 degrees here. And there they need to do a lot of serious work about balancing the booth because it's not coming straight down. And you have your water container at the bottom. You have your cascades that air needs to kiss every time as it goes up. And by the time it gets up here, it is, supposed to be purified. If everything is good, if the wall in the water curtain that's here, if it is completely uniform, but it's, when the spray booth is new, it does happen. You have a uniform waterfall, and the paint comes, and as it changes direction here, the particles go onto the wall. But with the quality of the water, with the scale that you might find in the water that could be deposited on the stainless steel walls, you might have some openings in that curtain. And therefore, when you have an opening, that means you have exposed metal, and the particle would hit right here coming in with the speed, and then it would bounce back because the water didn't take it down like it's supposed to. So a new water wash is good. As it gets older, it is a lot of opportunities for conversion. It's a lot of opportunities for both us as filter professionals, but also for the end user. Water wash systems traditionally are used for heavy applications. And up to lately, I'd say probably 3, 4, 5 years ago, when we came up with these extended surface filters, there was not a solution that could cover that heavy paint. You had to change the filters every shift, every 2 shifts, and so on, with the flat rolls. Now with the new products, you have the capability of changing. So again, for the end user, it's a very good opportunity, as good an opportunity for them as it is for us as filter professionals, bringing in a solution that works, because once they try it, it'll take away all the headaches of the water, having to clean the water with chemicals, having to treat the wastewater in a 2-step manner, which costs a lot of money. With the waterbornes, solvents are bad, but apparently solvents helped a little bit against bacteria in the water. So when you go to waterbornes, bacteria has, if you don't treat it properly, if you don't add the chemicals, you have a faster growth of bacteria in the water, and you have to be careful about that. So basically, today, if you have a waterborne paint and you have a good volume application, you basically need to have a chemist on your payroll to take care of the water and make sure it's healthy, first of all, to be in there, and also to make sure it's treated before you get rid of the sludge or the waste. Just a summary of a brochure that we have. Never mind the different arrays of different particles to accommodate all of these. But so summary is the filter, the downdraft, the air would be coming down through, whether it's water, glass, filter, polyester, paper, and then it goes right here and then up into there. In some applications, it recirculates through the recirculating unit or air makeup unit. The cross draft, again, bringing in the air, it goes across, and then across the filter bank, which is here, and then a final maybe filter, and then up. So the fan is, would be at this level, basically pulling the air up this way. So those are the 2 drafts, what do you call them? Flows in the spray booth. So when we talk about automotive industry, like I said earlier, the predominant or the most important or the most used system to scrub the paint off, the overspray of the system, or to take it away from the booth and then handle it, is the water system. And this is a very, very old style spray booth that you see in the diagram. You see the spray robots here or here, and you see, I intentionally put this one because it does show movement of the air, and it does show the washing. So particles come here, they hit the surface, they come down, they found this other surface, go around, and so on. So it's all hitting the water surface, try every time to grab as much of that mist as possible. So with the solvents being kind of like frowned on, not appreciated by the environmental, and actually, to be honest with you, in automotive industry, even the automotive companies, they have committed, they have agreed to reduce the amount of solvent-based paint by commitment to the environment. We want to have a reduction of VOCs, because treating VOCs, you need an abatement system. Treating VOCs costs a lot of energy, a lot of money, because you need to take those abatement systems to very high levels, temperatures. So again, it's a commitment. And everybody is on page, on the same page as far as doing that. The end users, but also a lot of work has been done by the paint manufacturers in developing these new paints that are less and less solvent based, going more towards a bio-derived water-based paint. When you do that, this is what happens. This is a solvent-based paint, the diagram of a solvent-based paint. It is, as you can see, made of pigments. It is made of petroleum-derived resins, which is what we're talking about, these elements. And it's mainly, or a big portion of it, is the solvents or the auxiliary agents. So by moving here, there was an immense reduction in these things. So CO2, it used to be this portion here. It was reduced by up to 60% by moving to the waterborne. The VOC in the paint or the solvents, by moving to the waterborne, you don't need as much solvents. You are reducing your VOCs by 80%. For an end user, reducing the VOCs by 80% is humongous. It's huge. It's huge in terms of cost. It's huge in terms of cost of treating the gases so they don't go into the environment, but also in terms of the booth itself, the costs, the initial investment for a new booth. The big part of the booth, it's not the booth, the sheet metal in the booth or the fan, it's what's in that abatement system. So if you reduce your VOC by 80%, think of how much smaller an abatement system you need for the same nature of application, or how much smaller footprint you need for that. So that's really a big change that we're seeing. The only problem is that when you go to this guy here, to the water-based, as you can see, the blue thing here is water. Okay. And if you use a water wash and your paint is based on water, separation of the paint sludge from the water before you dispose of it becomes a little bit more complicated. That means, again, you need to have a lot of additives, a lot of fragments, a lot of chemicals to make the separation. And this is why there was a creation. I guess people are developing, engineering companies like Eisenman, like Beer, like Taikisha. They are all, of course, the heroes in this, and they're the saviors, I should say, by coming up with these new ideas where they're using what they call dry scrubbers. These dry scrubbers, I'm not gonna have a lot of details on them, but all I know is that it's very costly to operate. And initially, when it was produced, it's good again, but it's a highly technical application. There's the electrostatic precipitators and the limestone enhanced scrubbers. Limestone is that they launch limestone into the airstream so that the paint particles would conglomerate and make bigger clusters, which makes them easier to be cut. So in this dry filtration, there was also some efforts from other companies and from us to create this high capacity filter that we call the PC pleat. And we first started by putting this in a floor, like a downdraft booth. And so these are the boxes. So the whole floor under the grid would have these boxes. They're very low resistance, good efficiency filters. And again, you don't have to change them like you change the rolls every 2 days or 2 shifts. These would last longer, extended periods of time, and you can go to 1 week to 2 weeks, depends on how much you're spraying. Other systems are now, they kept the pit principle because the use of gravity for the particle to come down, and they made in such a way that the air turns around at 90 degrees to go into these vertical walls that are filled with the PC pleats. So you could have a 1-wall pit or a 2-wall pit where air is recirculated again on both sides, and it turns around here and joins here. You know, it depends on how much paint you're spraying, how many cars you have running through that line, or how much you're spraying in total, basically. Can you hear me still? Hello?
Yeah, we can
Okay.
hear you, Mounir. I just turned
Okay.
off your video so we can have a better sound.
Okay, very good. So the PC pleat product, it's very high performance overspray arrestance. And traditionally, we use the same technology that we had in the rolls. It's the same, flexibility in construction, flexibility in layers, building in the honeycomb. It's also backed with some synthetics when necessary. It was supplied in rolls, was supplied in pads, cut to size for ease, or for modular walls where we had a 20 by 20 frame. And the filter that you see here is the high capacity pre-filter. And this is what it looks like after you spray some paint on it, basically. And the nature of this is unbelievable, because when you look through this, you could see through it. And then this is how it ends up being at the end. Of course, for this particular application, and that was at a plastics company, we had a secondary filter, but you see the loading, and this is how it works. The layers of paper are cut one way, and then they're layered in opposite directions. So the first layer with the blades would be facing one angle, the layer behind would be facing the other way. And that creates that movement or change of direction and the use of momentum of inertia to capture these particles. At the same time, the layers or the openings are gradually smaller as you go from the front to the back. So it's a combination filter of a shock filter and a mechanical filter, where the front is more open than the back. And this is how that red filter that you saw, it's a bumper color, and it comes from a company, a global company that does automotive parts. You go from the pad, and as it builds some of it in the front, some of it in the inside, and then at the end, you end up with that fixture that you saw earlier. And this is the layers. Synthetic if needed. It's easy to handle, no gas, no irritation, easy to hang, as long as you have those hooks in there. So in the roll form, this is what the initial, the beginning of this PCP, basically. Again, what you saw there, the turbulence, is what makes this filter load better than this one. This is an old slide that we saw earlier, but I just put it there as a reminder. This is the PC pleat. At 200 feet per minute, or at 1 meter per second, these are the initial resistance of the filter. Okay. So this is the what we're talking about is high efficiency, high holding capacity, optimal airflow, and all of those things that we talked about. I want to pause on this one here. Sorry. This shows us the performance levels. I think my presentation is going automatic on me for some reason, but we'll try and keep it here. This is the high capacity, high efficiency, and this is the high cap supra. These are the two main filters that we use in here. We can see the initial pressure drop is a little higher with the high efficiency filter, 0.105 versus a 0.076. Yes, 0.076. The efficiencies here with the high solids baked enamel is very, very similar. As you can see, it's an easy paint to capture. But when you get to automotive base coat, for example, you have a difference in the efficiency. But when you're in base coat, the difference of efficiency is not, huge. If your target is to be at 96% efficiency in the middle here, you're okay to work with this because, for slightly additional costs and also pressure drop, you're not gaining much neither in efficiency nor in really holding capacity. Okay, when does it become necessary to use this type of filter, for example, with the clear coat is required. If you're going to be at the 96%, by the way, I use 96% because that's the level that the OEMs were claiming when they were selling their turnkey operations with this kind of concept of filtration. Basically, if you go with the Supra 2, you're not going to get your efficiencies. And here, as you can see, you can hold more, but before you get to that point, you're letting out a lot of paint, like we talked about earlier. Okay? So this is pretty much a good number for a lot of the end users, and this efficiency is what drives the need or to use this filter versus this one. So again, it's all flexibility. Now let's say we start working with this guy here and we use that filter. And the end user comes and says, look, I need one more day or two.
Entonces, con los volúmenes que se tienen ahora, y se puede ir bien a los horarios de limpieza. Al estar dentro del filtro se cambia el papel y la composición del papel. Hay una organización sintética. Y es una muy buena solución porque tiene más capacidad.
Issues or requests. Why does this filter last so long, and why does it, capture so much paint without getting pressure? It's by design. It's really, when we say by design, it's in the design of the way the layers are put together, but also the way the filter filter pleats are put together, that the filter, the resistance to airflow stays flat as it loads with the paints, with the pounds of paint. And then at a certain point, then it goes up. So you would understand, if you look at the filter, is that we do all we can. There's an area that we hide from the airstream, and we accumulate as much as we can. We make the filter have turbulence within the layers, but also within the construction of the pleats themselves. So there's turbulence within turbulence. And that way we get, that longer life without gaining too much pressure drop. The automotive industry, this is a sample of a clear coat cart. As you know, some lines now, they have a cart that has 6 filters or 8 filters. It depends on the manufacturer. And it does give you the flexibility of having a cart ready, taped and ready to go. You take out one, you put the other one back in without stopping the line. And typically these lines will go from, I would say, 8 carts to 64 carts. It depends on how big they are. If they're in the same line doing primer, base coat, and clear coat, and that's really that's a big move from the automotive industry by having to make the primer cure in an oven first and then come back to be painted. And now we're at a process where you do primer and base coat at the same time, and then it cures, and then it goes to the clear coat. So that's, you can see the accumulation of that paint. It's automotive industry, also in any industry really. Wood industry, as you can see, manual spray. I'll go back to that. Every time I put the video on, something happens there. So what I'd like you to notice, besides the guy painting, is that the filters on top here, they're more loaded than the bottom, okay? The reason is these filters probably were, changed like a week ago. And these filters, according to this end user, he told me that these filters would last 4 weeks. So having the modular wall with the different openings does have advantages on changing the filters, only the ones that need to be changed. Okay, so that's a manual application. This is a automatic or robotic application. Again, the filters are behind, and as you can see, they're not too far behind. Okay, now again, it's moving on me. I'm sorry about this. This is the first time I use the application here. The quick facts that we talked about before, at 200 feet per minute, 0.1 versus, as high as 1.78 inches of water. The holding capacity up to 56 pounds, but really there's a point of, where you need to stop, because then you start consuming electricity. Even though the filter is capable of doing it, it's, again, also the weight and the operators having to take that filter out, the consumption of electricity because of resistance when it gets to that point. So there's a balance level where you don't need to go all the way to 56. The efficiency on average is right here from what we've seen so far. High efficiency, high holding capacity, and optimal airflow. Okay. A combination of the PC pleat and a pocket behind also has served as a very, very good solution for us because, as you know, we make polyesters that are designed for paint. We don't use pockets that are made for dust and just put them behind a filter, or rolls that are made for dust. We make media or polyesters that are designed for both dust and for paint. But specifically, sometimes if we want to do this combination, if we do the combination, that means what we're doing is we're having the luxury of, if we take the PC pleat and if we want to make it less efficient to make it last longer, we can, because we have this behind. Okay, and this is done through zone filtration, through using of non-migrating tackifiers, using other technologies like needling to consolidate or condense the particles, the layers in here, from here to here. For example, this filter does have the tackifier. This one is dry. Again, it depends on the particle. If it's a particle that's dry, this is what we use. If it's a particle that's very, very fine and that's still a little bit wet, but very extremely dusty, this is what we use. So it's a filtration system that really works. An example of the use of this combination. This is a aeronautical components manufacturer in Germany they have a side booth, an open face booth where they make some composites parts and they paint them. So as you can see, they install the pocket first. And as you see here, these pockets do not have a frame or a header. That's on purpose because we use the media to seal against the framework, the lip in the back of this framework. When it receives the polyester in here, you have a natural hermetic seal. You don't have to worry about bypass or having your paint go through. So you do whatever you want with the PC pleat. You know, you relax it, you make it more efficient, less efficient. You accommodate your end user to get the service that they need, the efficiencies that they need, and the booth, you know, balance that they need. Really, this is not, I'm not joking. These guys do love this change, you know, and they have 15 spray booths. They started with this small one. I think we're at 7 booths now that have been modified, and there's, you know, the rest is coming after this pandemic, you know, goes behind. Another automotive plastic parts feeder. This is a major one. It's a very well-known company. We came into one booth. They basically asked us to come in and help them solve. They were in a situation where they were deciding whether to go for a water wash booth or explore this PC pleat situation. Okay, it's a very it's a very busy booth. It's a lot of paint that's going through it, you know, every day. So they had 2 layers of polyester, 1 and 2. They had a panel in here, and they had a pocket. Okay. As far as the air is concerned, they were exhausting out to the outside about 10 to 15%, and they were exhausting through the absolute filter. You know, it's a MER 14 filter up to the AMU, and then it's coming back into the booth. Here's the situation as far as the filter life, the surface area of that specific primary filter, secondary, and so on. The first filters, the 2, they have to change them every 6 to 8 hours. So after 6 hours, they take the front one out, and then they run for another 6 hours, or 8 hours in the front one, and then 6 hours of the second, because the second had already seen some paint. You know, they can't have too much efficiency here because otherwise it's, you know, it's too heavy on the airflow. And they were having issues with the, you know, with the airflow really imbalanced because of all of that stuff. Okay. The filter, that's the panel, they were changing it every 24 hours. So it's a sacrificial, that's sacrificed to save the pocket behind, basically. Every 24 hours, they take that panel, put the new one. You know, the cost of the panels, you know. But if it's 24 hours, that's 320 days a year. That's 320 times, this booth had 78 openings. So you can do the math of a sacrifice that they had to do to keep running. The polyester pockets they had in there, and they stayed 2 weeks. But here's the issue. When they went more efficient on the pocket, they could not run, because, I mean, it was this more efficient, higher resistance, and then the mini pleat that was up here, it was just too much for the system to handle. Okay. So they were changing that every 3 days because they had these fine particles get up there, you know, that were going through here because it was not that efficient. The target, and when they said, look, if you give us 112 hours of operation, we will go with you. We will not go with the water wash. They did their math. They did the, you know, it's a weekly change, and that's what, you know, that's the goal. So we went on. This is the application. It's a robot application, very heavy paint, a lot of parts going through. And we went in with the combination of the PC pleat and the pocket. Remember, they were changing filters every 6 hours. The back filters every 3 days. The other ones every 24 hours. This is a photo that I took from the reading when we installed the line. And this is 3 days later. So you can imagine how much pressure drop this thing gained after 3 days. That's, I think it's 7 shifts. They don't do 3 shifts. They do 1 and 1.8 days, so 1.6 or something like that. So after 7 shifts, the gauge did not move. It did not move at all, you know. So already after 3 days, they were just ecstatic because they just did not go to the booth to change filters. They didn't have to deal with it. And, you know, this is the front of the filter. The combination was our PC Pleat 500 HE and our SL92B pocket behind. And we are working still. We didn't just sell it and go away. We are still working on improving the situation right now to extend it a little bit more, or to make the SL92B last 4 weeks maybe instead of 2 or 3. You know, this is the front of the filter, and you can see how from here all the way to the end, the booth is evenly loaded. We, in this booth, we actually tried to do the hotspot, but at the end it was not possible because I'm not joking. All the boxes were within 2 pounds. That's how air was flowing through that booth. It was fantastic. Anywhere you look in the booth, it's movement, you know. And they also sprayed in 2 robots, one in the beginning, one at the end. So that covered both areas. This is what the filter looks like when you open it to look at it. This is the way that this particular paint accumulated inside the PC Pleat, as you can see. It actually builds its own matrix, and the cake of the particles kind of becomes a filter, but air is still going through here. And then behind these 2 columns, there's an area back here that's hidden, that does not see any air until everything else is closed. Here's the kicker. When we look at the PC Pleat, the loaded PC Pleat that's about to be taken out, the one that you saw from the front picture, this is what it looks like in the back. You can see how clean the cardboard is right here. There's no, you know, particles in there. You can see a little bit on the sides here. That's the finer particles that made it to the pocket. And this is why we could probably relax, I think, the front filter a little bit longer to make it last a little longer and make the pocket work more, you know. So it's a compromise between the life of the pocket and the life of the PC Pleat. But I think what we're still trying after, you know, they're happy with the production, but we're still trying to get to a balance where we have the ideal situation. And you know what, from my experience, every time you get to the ideal situation, purchasing or technical comes in and say, oh, we're going to change the spray gun. Oh, we're going to change the type of paint or the supplier of paint. It's, you know, and then you have to start all over again. But you have the tools to do it with the PC Pleat and the pocket. The matrix of the PC Pleat itself, but also the pocket itself. These are the pockets behind. The operators, now they can go in while the booth is running. Before, they could not go in. It was foggy. It was all this, you know, paint. You know, remember, this is before the mini pleats, right? The chamber behind the area behind the pockets before the mini pleats. So it was all foggy. They couldn't see. I mean, they had to wear protective stuff, and they never went in when the paint was the booth was running. We were in and out a couple of times while the booth was running. So if I summarize this situation, this is what I'm talking about, this area here. Okay. Now, the one thing that I was also concerned about, and I'm glad we covered it, is that this part here had particles in it, a lot of particles that went out to the environment, you know, because it didn't go through this. The target was 112 hours. We reached 120 hours of the PC Pleat 500 HE and 240 hours, and 240 really because they changed it systematically after 2 weeks. They didn't try to go the 3 weeks because they didn't think they were going to get there. I think the pressure drop that we were seeing after the pocket was probably still feasible, but I could not confirm it to them 100%. So they decided at that point, and this is what we're working on right now, to take this to 3 weeks. That's what we're trying to do by, you know, either by the combination of the 2 filters, basically. So now in this situation versus this, the stuff that's here is a MERV 14 filtration. This pocket is MERV 14. It's not like the other one where it was, I think, MERV 8 or MERV 9. This is 14. It's as efficient as this here. So anything that's out here is pure, it's clean. You know, if it's good enough to come back to here, it is clean, you know. And of course, the pre-filters, the panels. Another exhaust system, this is in the US. This is where the filters are. It's a robot application. Again,
Mounir,
yes.
we have 10 more minutes for the presentation, so we have time for question and answers.
Okay, very good. We will go, I'll try and speed it up. Again, one wall underneath the booth, air goes around and goes out. The advantage of this PC Pleat is the ease of installation and removal of loaded filters. This is the metal structure. This is, you fill that up, you fill your wall, you tape between the filters. So to make sure no particles go between the filters. This is the way it looks in the back. They had a filter behind here, you know, but with our PC Pleat, they did not need it. They ran for, I think, 2 or 3 weeks with this, and they were very happy. But when we mentioned the possibility of adding efficiency right there, they went with the pockets also. So that's the same with there. But this time they used the 65B, which is a different filter from the other one, the 92B, because the particles did not require the 92B. Another thing that we do is we measure the energy consumption. We compare the average pressure drop from start to end of our filter to other filters. And we can actually, we have a calculator that you can use, Jorge and team, that actually calculates how much electricity you're going to be consuming in, you know, how much electricity you're consuming in 1 year for every single opening, you know. And just this situation that we were looking at, it used to have this filter in it, and it saved them for every opening in the factory. It saved them 261.32 euros or dollars. This formula is euros, but $261. If you take $261 and you're changing your filters every 2 weeks, you're looking at half of your filter cost being paid by just the electricity that you save. Not to talk about the efficiency, not to talk about the less labor and so on and so on. This is love that CI product, and really this is a company that I love also because they have gone with our recommendations. First, they're a water wash. They're an agricultural equipment manufacturer. They had issues with the water wash and so on. The water wash was getting a little, becoming a problem. We converted them to the high cap Super 2, the regular rolls. They were happy with that. When we introduced, so this is the high cap Super 2, as you can see, or the Super 2 media in here. It's a big booth. It's spraying from this side, and the other operator is spraying from the other side. This platform goes up and down because the parts are pretty big sometimes, and they have an elevator, and they go up down on it. A lot of spraying. And so they moved to our rolls, and they were happy with that. Then when we introduced the PC Pleat, they went to the PC Pleat. So this is one of the 2 sites where we installed the PC Pleat, and they're very, very happy. The thing is that, this is what the filter looks like in some of the hot zones, hot areas. The good thing about it is that in this situation, the end user is happy. The distributor is happy because as far as income, it really balanced itself. But actually, our distribution partner did guarantee the service there. In doing these moves or changes, it's not very invasive. We don't have to do much to make a trial. You don't have to have a lot of hardware put in there to put the filters in there. This example here, which is that plastic part, this is when we started. We actually stacked the filters on top of each other, and I used some corner board that's used for skidding for the pallets to support the bottom ones, so that if the weight is heavy here, it will not, crush these, because you're talking about 1, 2, 3, 4, 5, 6 filters. The bottom one needed some support in the middle and here. So we used cardboard, reinforced cardboard, corners to support that, and made the trial. Then later on, as a temporary solution, all they had to do is take the old frame, and they made a little extension with sheet metal that was screwed in, in here, or riveted. No stoppage. On the Sunday, they did this, or Saturday, and boom, they put the PC plate in there. Another idea, this is for that agriculture equipment. What the distributor used this as a trial shelving to do the trial. That shelving is still there. And it's been like 2 years or 2.5 years now since they did it. So it's a very clear, if you have somebody that does sheet metal, it's a very simple thing. You just need to place something where the filter can be positioned with these edges or these ribs, and that's it. And you just, because after all, you're taping between the boxes. So you have no issue in hardware trials and so on. If you, Jorge, or anybody needs some sort of like an indication, sketches or drawings, how to make this, I can ask. He's very helpful. I can ask for that for you. So this is the, again, that picture where we moved from water wash to dry. Besides the PC pleat and the pits and the carts, there's a new system out there that was introduced by a company, Eisenman, and it's called the E-Cube. And for that application, due to heavy demand from our customers and friends, we did make a product that's that is replacing exactly where it fits, exact parameters, exact interface with the line, and so on. So this is by heavy demand from our customers, because there was a shortage of these filters for a period of time. This is in the booth.
We have 5 minutes.
Okay. I think I'm good. This is a trial. This is the trial that we're talking about here. And this is what we did in a mix of E-Cube and CI Autobox. This is what the results are. And
y esta es la capa base. Este es el peso máximo. Este es el peso aquí. Este es nuestro promedio. Y pues están viendo a un 160% de capacidad en comparado con el equipo original.
The filter, the second filter, which is pocket, the life was extended by as long as 2 weeks compared to the original, because we do study the particle, we do testing in our lab. And by the way, the performance of any filter or any situation will change with the change of any of the parameters. And this is the pressure drops of a clean filter. And this is the modified, this is the paint lab testing. And how do we evaluate filters? Where do we recommend to use what? We have a full-fledged lab where we do paint. All we need is for the paint to be supplied to us, and all the testing is free. You tell us what your goals are. You have your end user send us the paint. We do all the testing for free. This is a tunnel that we use. We use, again, arrestance by weight, just like the ASHRAE, but we use paint particles instead of dust. And we do what we call, this quantity here is called an increment. And we do by increment, and then we evaluate the initial, the final, and then the average for all of the values. There's a form that needs to be filled out. There's a procedure on how to go about sending us, a paint test, and I can send you that by email. There's the different steps, and then this is what the form looks like. As much information as we can. That's our lab. Thank you very much. I appreciate your time. Thank you for bearing with my Going too far, too long. Thank you.
Thank you so much, Mounir, for your great presentation. We really appreciate all these new technologies. And as you start in your presentation with the 101 of the paint booths, what is the velocity, the area, the type of paint, type of paint booth and everything. So thank you again, Mounir, for your presentation. Patrick, Steve, also for your time, your knowledge, and all your support. Y bueno, quiero, Mounir, if you want to say anything else before we almost end this presentation. Steve?
Yes, first of all, I want to thank everybody for the opportunity, for the time. And also, I cannot say it enough of how much we do for our customers and how much we put at their disposal in terms of technical, in terms of support, in terms of equipment, our lab, our people. You know, we are very loyal to customers. We thrive, and we've been in the business since 1965. Long-term relationships, mutually beneficial relationships, innovative relationships, contribution to the environment, to the you know, to the community, to our world, to the future for our children. Anything that we can do towards that is more. We're more than happy to do it. And again, every time we get some work, we try to something to work on. We're very, very appreciative of the opportunity. Thank you very much.
Thank you, Mounir, for your presentation. And we have some questions.
Yes.
And I want to read it. Ulises Delgado is asking, what material is the paint arrestor that isn't fiberglass? Will it work properly with the UV coating?
Yes, it will definitely work with UV coatings. We've got multiple applications out there, such as golf balls and hospital equipment that are painted with UV coatings, and they all are atomized at different rates. But we got some that are hitting very fine, ultra fine, where we had to increase the efficiency, and we've had others that actually hit the filter actually almost like honey or glue hanging on this UV. And of course, it never cures. But the goal there was to keep that stuff from going up and out the stack, because if you can imagine a UV coating not curing and getting in the stack, it basically ruins the stack and the fan.
We have a lot of customers using UV in bottle or cosmetics painting.
And but you can use a PC plate on this application, or what type of filter do you recommend?
It depends on the volume. I do have an application in cosmetics in France where they are using the PC plate, and they are using a more open PC plate, and behind they have a Supra 2 or a Supra 1 behind as a roll, not a pocket, because they didn't have the space. What's nice about it is that they have the roll on a frame, a metal frame that's on a rail that you can pull out. So they're using the PC plate as a buffer. It does capture a lot of that liquidy, runny stuff, and it protects the secondary filtration. But they're having, in some applications, they have several spray booths in this application. They are changing the secondary filter before the first one sometimes.
Okay. Yeah, we have another question from Cesar. If, ¿cómo funciona? If the PC plate can be used for any type of paint, or it have to be a specific type of paint?
With the flexibility of the layers, it could be used with basically any paint. There are some paints that are difficult for any kind of filters, you know. But the advantage of the PC plate is that, another advantage also is that the air is not hitting the face flat. It's hitting it at an angle. And using the combination of the structure of the V's themselves, using the combination of different paper layers, matrix. Yeah. Steve, do you have something else to say about that?
Well, I mean, even going back to the question with the UV coating and then this question here as well, this is where our lab, where we can develop a product if they're having problems to meet their needs. It's not like you got to use this filter and good luck. We will do the engineering and all the background work to meet the needs of what the requirements are of that facility. And we typically find the work that we've done in the lab will show an efficiency rating, and then we'll show a holding capacity. The efficiency rating, we'll see that as good or better out in the field, and also the holding capacity as well, because we're spraying, as Mounir showed that test duct, we're spraying within 6 feet of that filter, and there's nothing in front of that to disturb the air. So, our filter in the lab is getting the worst case scenario that filter would ever see. So when we're in the field, that disbursement of air is spread out a lot, farther out, and it's not as concentrated as heavy.
Okay. Martin Ocampo, also he sent a question. What will be recommended filter system for rotary belt applicator, solvent bore material? The current state we have is bag filters, secondary panel filters, and blanket filter. Get changed every 2 hours. I think it's almost the samples. Yes.
Yeah, these are applications. When I see somebody change the filters out every 2 hours, I just get all excited. I mean, that's where we take something like this to the lab and we engineer something to last the entire shift for them. And with having the capability of just the expanded craft paper to increase service life, we've also got the PC pleat to fall back on to increase it even longer.
We do have some rotary application, and it depends on how many towers they have in the circumference where the PC pleat is. I just was in one in Ohio, Steve, for you because of the pandemic, down the street from here. It's like an hour and a half from here. And yes, it is feasible. It is possible to put it in a rotary application, but it's going to have to be in like wedges, not the whole thing. And believe me, if you have a 2-hour change, when you have the PC pleat, you don't need to cover the whole surface. And you're going to be running much, much longer than that. I mean, the goal is to get you to, the 1 week is what usually the magic number for us. And we will do whatever it takes to get there. If we can't, I'm sure it's going to be longer than 2 hours. And when you look at your costs, you're going to be saving a lot of cost in terms of everything, and the filter is not, this is where I was talking about is a combination of the filter and a pocket behind.
Okay.
Now one thing to keep in mind, people spray a lot more product than just coatings. You've got a lot of adhesives out there, and our products are really known out there in the industry to increase the service life there. I had one of my first applications where they were spraying contact cement, and it's kind of funny, the guy mentions 2 hours. They were changing fiberglass pads out every 2 hours. We went an entire shift with our high cap Super 2, just the roll filter itself.
Okay. Muchas gracias. Ulises Delgado hace también la pregunta que si los PC pleats pueden ser de medidas especiales, custom size. Can the PC pleats be custom size or has only one size?
Right now in the US, we have one size. The face is a 20 by 20 nominal. The depth is also 20 inches nominal. However, we have in our plans to add, to answer to several requests that we had for the industrial application, not automotive, where a 12-inch would be required instead of a 20-inch deep. For what we've seen is for the applications where we're at like 4.5 pieces in the width or the height, because of the low resistance to airflow, most of the time people would put a piece of metal to close that gap, and we're done, because the capacity of the filter, you know. If the question is about a quantity, I mean, a dimension that's off, that's special, if the volume, like we said, we never say no, if the volume is there in terms of purchasing quantities for components, and you know that would justify buying, you know, from these paper companies or corrugated companies, you know, we would look at it, we would entertain it. Again,
Okay.
so thank you.
Okay, muchas gracias, Mounir. And another question from Ulises. Otra pregunta es, ¿cuál es el costo para las pruebas con un pouring, con una pintura específica, y cuántos litros se necesitaría del producto? Which is the cost of the test on a specific coating? How many liters of the product will you need to run the test?
Well, I'm glad somebody asked that question, because we do that testing at no charge in the lab. We do that in order to you know, earn the business and promote the best product that we can out there. So we do that at no charge. And as far as how many liters, Mounir would have to go back to liters, because my conversion from gallons to liters
Gallons.
isn't great, but we typically require at least 5 gallons of coating. And some coatings, you know, we've run some tests that we can run 2 or 3 tests, and we still got paint left over. I was talking to the lab today. He had one test that he ran, and he had 16 tests that he had to run. So he used a lot of coating beyond the 5 gallons.
Okay.
The thing about the testing, also what we do, as you saw in that tunnel, even if it's a PC pleat, what we would first do is a preliminary test. It is referred to as the face, or like a flat sheet test, to see how the paint behaves in the matrix of the expanded paper. And then when we qualify the media or the stack up that we feel is good, then we go to the PC pleat test. So the initial does not require a lot. If, for example, you would like us to do a preliminary test only with flat sheet only, and then you buy a quantity that's going to fill one booth, you know, the whole thing, to do a test. And so at least when you do that, your field test is not going to be a waste. It's going to be something that's very, very close to where we need to be in real life, because we do the flat sheet with a lot less paint, of course.
Okay, thank you. Y bueno, 5 galones son 20 litros aproximadamente. Eso es lo que estaríamos necesitando para la prueba, y bueno, sin ningún costo. Héctor Escobar también hace una pregunta. ¿Conocen un monto aproximado de la inversión del cliente para realizar el cambio a usar los PC pleats? Es decir, acondicionar los bancos de filtros, hacer una nueva estructura. The question is, how much can be the cost to realize a test on the PC pleats, to have the frame together and install the PC pleats around the test?
For the test, I don't think it's a lot. Like I showed on the video or on the pictures, we can manage with temporary, support system, because the filters will stack on top of each other, and all we have to do is get some support beams. They could even be made from wood. They could be made from steel, preferably steel, because some, spray booths would not let you use wood in there. But like the samples that I showed, the shelves you could put filters on. If you have an old frame system, we could make extensions. We could, it doesn't have to be an extension like the one you saw. It could be cross concrete wire, ribbed wire, where we make squares in the front and the filter sits on it. So it's really, we will do whatever it takes to make it not costly. If you have several booths, it might be worth it to get some kind of a structure that you can use in different booths to do your test.
Okay, excellent. And the last question is from Ernesto Correa. El filtro PC Pleat requiere un prefiltro, puede funcionar directamente con la pintura. If the PC Pleat requires a prefilter or can be first stage.
It could be a one-stage filter. If, you know, it could be, like I said, we can combine with pockets behind, or it could be on its own. But, you know, the more you do in the booth, the less you're going to have in the ductwork and in the AMU. If you're just exhausting outside and you're returning into the plant, we have the high efficiency filters. We could add any kind of, you know, synthetic medias. And Steve, you can go again on that initial when we did in down in Missouri, and you did the one with the HE first, and then you added the pockets. Could you tell us why you added the pockets?
Well, the pockets were added. It was the recirculating air that was coming back through the booth, and we added the pockets in order to keep those filters up top, you know, a lot cleaner. Once we added the pockets, the high efficiency filters that were on in the houses that were stacked up on top of the booth, they noticed when they put a clean set in, they stayed clean. But before we put them up there, we're just running the PC Pleat, we saw a very little bit of coating that actually got on the filter. In other words, it stained the filter. It really wasn't paint loaded. All it did was just change it from white to a very light gray. So, and then the other thing with our filters is with and this is all backed up behind the expanded craft paper to depth load the coatings in the filter. The paper, you do not want to cover that paper feature up, because that's what's allowing that filter, you know, to actually depth load. So anything that you put on the front as a pre-filter is most likely going to be very short in life.
Okay, excellent. So thank you again for your time, for your knowledge, and for sharing all this information with us. And well, voy a continuar ahora en español.
Okay.
Si alguien tiene alguna pregunta o algo, pues con mucho gusto lo podemos hacer, ya sea en el chat o continuar. Bueno, pues ahora sí que continuando y platicando un poquito con ustedes, los Air Quality, bueno, no me presenté por ahora sí que los nervios de empezar un poquito tarde con las fallas de este tema del traductor y demás. Pero bueno, me presento, mi nombre es Jorge Velasco, gerente general de Air Quality de México, y la verdad que es un gusto para nosotros poder traer estas pláticas, estos webinars, para poderlo compartir con todos ustedes, el tema del conocimiento, el tema importante de tener las herramientas necesarias para todos ustedes que lo tengan en sus plantas, en sus empresas, y puedan dar esas mismas soluciones. Ese es el primer webinar que vamos a hacer, una serie de webinars ya que vamos a estar lanzando durante todo el año. Van a ser 2 webinars mensuales y con diferentes temas. Ahora, como pudimos ver, Columbus Industries nos acompañó, y la ventaja que tenemos con trabajar con ellos en todo lo que es cabinas pintura es que, como lo mencionaba Mounir, Steve, Patrick, es que ellos son fabricantes del papel, fabricantes de la media filtrante de papel y fabricantes de la media filtrante de los poliésteres. Entonces, con su laboratorio, ellos nos han ayudado a desarrollar filtros muy específicos, hablando del PC Pleat, para las soluciones en diferentes empresas, ya que mencionaba pues que viene una capa de papel, viene una capa de poliéster. Entonces, ¿ellos qué hacen? Bueno, le pueden poner más layers de papel, le pueden quitar más layers, perdón, quitarle layers o capas de papel y ponerle diferentes poliésteres, diferentes anchos o estructura de poliéster, sin tackifier, con tackifier, o sea, realmente se puede hacer un sinnúmero, ahora sí que un filtro a la medida para cada uno de ustedes, ¿no? Y lo único que necesitamos, como comentaban y preguntaban, son 20 litros de cada una, a lo mejor si tienen 3 etapas de pintura, 2, 1, pues esos 20 litros las mandamos directamente a su corporativo y de ahí se corren estas pruebas. Y bueno, ahorita también agregué a la pantalla o aquí con nosotros, si pueden prender las cámaras, a los gerentes de las diferentes áreas de Air Quality de México, donde estamos a nivel nacional con 8 sucursales y que podemos dar todo ese servicio, ese soporte técnico, esas visitas para encontrar una solución. Como Mounir, Steve y Patrick, tenemos todo el soporte y lo importante es encontrar esos ahorros para ser más competitivos a la empresa, ¿no? Evitar menos contaminación al medio ambiente, proteger a las personas que están trabajando y con gusto hacemos esos levantamientos, ¿no? Y buscar esas soluciones. Voy a ir presentando rápido, porque ya ahora sí que nos ganó el tiempo, pero bueno, como los tengo aquí en la pantalla, César Valdés, nuestro soporte técnico a nivel nacional, Marcos González, gerente de la sucursal de Puebla, Alejandro Velasco, nuestro director de ventas a nivel nacional, también encargado y gerente de la sucursal de la Ciudad de México, el área metropolitana, Antonio Miranda, que él está en la sucursal de Mexicali, atendiendo todo el noreste de la República, Carlos Alcázar, que está en la ciudad de Guadalajara, atendiendo el occidente de la República. Bueno, Ernesto Correa, soporte técnico, él está en Monterrey cubriendo también la parte noreste de la República. Héctor Escobar, que está directamente en la división de líquidos, que también es algo nuevo que no habíamos comentado. Air Quality de México ya hoy día tiene un acuerdo global un acuerdo de distribución con Global Filters para manejar toda la filtración líquida y que de hecho la primera semana de marzo sería el lanzamiento, digamos, el webinar de líquidos. Y bueno, y tenemos a Israel Cázares, que es nuestro gerente de marketing de Air Quality de México. Por ahí faltaron algunos gerentes de que se pudieran conectar, pero este es todo el equipo, parte del equipo de gerencia que estamos para trabajar con ustedes, apoyarlos y encontrar estas soluciones. Con estas nuevas tecnologías, la verdad que el PC Split ahorra muchísimo en energía, ahorra muchísimo en filtros y la otra es que es 100% incinerable. Entonces también puedes encontrar una parte hacia las cementeras y hacia los demás, o sea, ayuda a cuidar al medio ambiente, es lo que quería decir. Y pues no me queda mucho más que agradecer de nuevo a Columbus, a todo el equipo gerencial de Columbus y a todo el equipo de Air Quality de México, a Israel, por traer este webinar en línea, primera vez con traducción simultánea y seguro vamos a ir mejorando esta parte para empezar puntuales y no batallar en la traducción. Muchas gracias y esperen noticias. El webinar fue grabado, les haremos llegar por ahí un link para que puedan bajar y puedan volver a ver esta presentación. Cualquier duda, cualquier pregunta, estamos en www.acudmexico.com. Los teléfonos que los tengan. No sé si alguien, Israel, pudieras poner o algún panelista el teléfono de oficina matriz, o si no tienen, y si no, la página de Air Quality de México para que todos la tengan. De nuevo, muchas gracias a todos. Buena tarde y seguimos en contacto.
Buenas tardes. Chao. Thank you.